So I'll be talking about how we determine the order of an implicit run cutter method. Now the first thing we should say is that an S-stage implicit run cutter method can have order up to 2S, but just because you do have an S-stage run cutter method doesn't mean you have up to order 2S. Okay, so what I've got here is I've copied this from the lecture notes. So these are order conditions, so these are using the derivation of run cutter methods. So we have a B, a C and a D order condition. Now what we can say is if BK is satisfied up to, so if this first order condition is satisfied up to some value K, and C condition is satisfied up to K divided by 2 rounded down to the next integer. So here I've got the floor operators. So if we have K, we halve it and then just take the integer part. So if C, this order condition, is satisfied up to half K rounded down, and the same for the DK condition. Okay, so we're looking for a number K where these three conditions are satisfied. So what we can say is that then if this is satisfied, we have a kth order method. Okay, so what we're going to do is I'll show you by demonstrating with a example. So I'm just going to sort of rub out some of this stuff, and this example is taken straight from the notes, but I just talk through it. Okay, so the example I'm going to use, I just write it as a butcher tableau up here. So I've got an implicit run cutter method. We have B values of 1/2 and 1/2, C values of 1/4 and 3/4, and we've got A values of 1/4, 0, 1/2 and 1/4. And this is example 3.1 in the notes. So straight away we can determine that it's an implicit run cutter method because we have non-zero values on the main diagonal here. Okay, so what we're going to do is we're going to first check BK, and essentially what we do is we increase the value of J here until we no longer have the left hand side equal right hand side here. So first check for J1. So if I expand this summation, we have two stages, so I should note that this is a two-stage method. So we have two stages, so we have a summation between I is 1 to 2, so we have B1 C1 to the power J minus 1, well in this case J is 0, sorry J is 1, so that's 0, plus B2 times C2 to the power 0. So I must actually say that's the left hand side. Okay, so B1 is 1/2, anything raised to the power 0 is 1, and B2 is 1/2, so we have a left hand side is 1. Okay, what about the right hand side? So for J is equal to 1, we have 1 over J, so 1 over 1 equals 1. So in this case we have the left hand side equal right hand side, so we know that that condition is satisfied for J equals 1. Okay, let's check it for J equals 2. So this time the power of the C values is incremented by 1, so we have C1 to the power 1 plus B2 times C2 to the power 1. Okay, so we have 1/2, which is your B1 times 1/4 plus B2 times C2. Okay, so that's going to be 1/8, and that's going to be 3 over 12. So that's going to be 1/2. So do the same for the right hand side. It's going to be 1 over 2. So right hand side is 1/2. So you can see left hand side is equal to right hand side. Okay, continue for J is equal to 3. Okay, you start to see the pattern emerging with the order conditions. So here's the same, but we just square the C values, and okay, and if we work out what that is, that's 5 over 16, and the right hand side condition of that condition is 1 over 3. Okay, so what we have here is left hand side is not equal to right hand side. So the maximum order this could be is second order. So this is maximum order 2. So what I now need to do is if I halve 2 and round down, obviously that's just going to be 1. So I now need to check the C1 and D1 conditions. Okay, so checking the C1 condition. Okay, if I just go back a slide. Okay, now the C1 condition, we have two variables here. We have L and I. Now L goes from 1 to K. Well, in our case, K is 1. So L is always 1, but we have to check I going from 1 to 2. Okay. So for the C1 condition, so checking for L equals 1. So when I equals 1, the left hand side. Okay, so this is going to be A11 C1 to the power 0 plus A12 C2 to the power 0. So I'm getting these from the equations in the lecture notes. Okay, so A11 is 1/4 times 1 plus A12 is 0, so that's equal to 1/4. And the right hand side for the C condition is 1 over L, so 1 over 1 times C1 to the power L. That's going to be 1. So it's just going to be C1. So right hand side equals left hand side, so that's satisfied for I equals 1. Now we need to check for I equals 2. So left hand side is A12 C1 to the power 0 plus A22 times C1 to the power 0. Essentially, when L is equal to 1, the C condition is also known as a row sum condition. So we have 3/4 for the left hand side, and for the right hand side, do similar, but for the second row, oh sorry, I was going to say I was just carrying on doing the left hand side one there. So the right hand side is 1 over L, so that's 1 over 1 times C2 to the power 1, so that's just whatever C2 is, which is 3/4. So we can see, but C1 condition is satisfied. Okay, so what we now need to do is determine the the D1 condition. So okay, so this is a D1 condition, same as before. We need to check it up to K equals 1, so L will always be 1, and we have different values of J being 1 and 2. Okay, so now we're going to check the D1 condition. Okay, I'm going to change the colour because I'm bored of that colour now. So D1, so this is when L is always equal to 1. So this time with the D1 condition, so when J is 1, we have the left hand side is B1 times C1 to the power L minus 1, which is of course 0, times A11 plus B2 times C2 to the power L minus 0 times A21. Okay, so B1 is a half, C1 to the power 0 is 1, and A11 is 1/4. B2 is also a half, C2 to the power 0 is 1, and we have A21, which is a half. So what we have here, we got 1/8 plus 1/4, that's 3/8. So the right hand side for the D condition is 1 over L, so it'll be 1 over 1 times BJ, which is B1, 1 minus CJ, so which is C1 to the power L, which is 1. Okay, so this is 1 over 1 is 1, B1 is a half, 1 minus C1 being 1/4. Okay, so it's a half times 3/4, that's 3/8. So the D condition is satisfied when j is 1. What about when j is 2? So we have b1 c1 0 times a1 is 2 plus b2 times c2 to the power 0 times a2. So b1 is a half, a12 is 0, so b2 is also a half, but a22 is 1/4. So that equals 1/8. Okay, for the right hand side, so we have 1 over L again, b2, 1 minus c2 to the power 1. Okay, so b2 was a half, and c2 was 3/4. So a half times a quarter is 1/8. Okay, so both these conditions are satisfied for j is 1 and j is 2, so therefore D1 condition is also satisfied. Okay, so what does this mean? Right, so if I just clear that slide. Right, so what this means is we have C2 is satisfied, and oops, sorry, that's not C2, it's B2. So we have B2 is satisfied, and we have C1, and we have D1 satisfied. So this implies we have a second order method.